Hello everybody. Hope you guys are doing well. So in previous lectures we learned about set timeout, right? So now we are going to learn. So we are just going to implement a little bit code like some functionality. So yeah, let's try to implement um some code. So we'll be implementing debouncing and throttling. So let's see first what do you mean by a debounce function, and then we'll try to understand. We will understand. Uh, we'll try to understand how. Uh, yeah, let's. So let's see first. What do you mean by debouncing? So let's see. We need to write a debounce function, right? So because a debounce function is the one that is executed. So this is going to be executed only once after a certain amount of time has passed since uh, since the last time it was invoked, regardless of how many times it is triggered. So since the last time it was invoked, regardless of how many times. So regardless of how many times it was triggered. So basically, what is going to happen is, suppose this is basically like a switch, right? So it's debouncing is like a electrical switch thing, right? Executed only once. So for example, after an interval has passed, so a fixed interval of time, so only then we are going to invoke the function. So we need to keep a track whether that specific interval, so after this interval, after this, so basically this time gap has to be completed irrespective of the so it may be triggered here here, but then we need to hold that function, or we need to keep a. So in set timeout, the what you can do is basically first is something that we need to define an interval here. So let's have an interval. Let's set that after every 100 millisecond only we need to call the function only after that specific amount of time has elapsed, right? There should be an event that is going to occur, and then we are going to for example, when we trigger an event, it should not immediately call the function. Instead, it's a timer to execute the function after a specified delay. So there is no repeated. Are we to call it repeated? I guess we are not calling it repeatedly. So so interval, what we'll do is it will keep on calling that function after a specific number of time, right? If you have say set the interval done, so the callback is going to be triggered after that. But when the event is triggered, so when we call the function, instead it sets a timer. So what we are going to do is we need to set a timer to execute the function after a specified delay, even if the event is triggered again and again before the delay is over. So there is something or somewhere where we need to keep a time track of the time, right? Like the time track has to be kept so that even if the timer has not elapsed, we shouldn't be calling the function. So for example, this ensures that the function is only calling once after the event stops firing. Mm, let's see. So by triggering is basically function call should not happen here. That is what is saying, right? So suppose this is at time equal to 0. This is the first time the function will happen. Then we can make multiple calls, right? Uh, we can call the function and again. So we should not be calling it unless and until we have completed, say, this 100 milliseconds. So we have to, and it can be called, even though if it is called, we have to derive a mechanism or something so that the function doesn't get invoked here in this period. Okay. So now interval will call it repeatedly, right? We don't want that. We are not keeping a track of the interval. We don't want that interval tracking to happen. Instead, we want to call the function, but then only after a specified time. And if the specific function is getting called in between, we need to you ignore it. Okay. So how are we going to keep a track? Um. Okay. There is some mechanism that we need to develop, right? So that uh, let's let's this ensure that the function is only called once after the event stops firing for the specified time. If the timeout hasn't occurred yet, uh, okay, let's see. When the event is triggered, it doesn't immediately invoke the function. Instead, it sets a timer to execute the function after a specified delay. If the event is triggered again before the delay is over, the previous time has to be cleared. Okay, so now this is something new. This is not entirely what you mean. So he's saying debouncing is a technique to ensure that a function is only executed once after a certain amount of time has passed in the launch time, regardless of how many times it is triggered. It's commonly used to limit the number of times events like okay. In the context of JavaScript, the debouncing is more often. Now, how debouncing works is when the event is triggered, it should not immediately invoke the function. Instead, it sets a timer. Okay, so suppose at time equal to 0, I'm going to invoke it. It shouldn't get invoked here. We have to wait for that specified time to pass. Instead, it sets a timer to execute the function after so you specify a delay over here and then you execute it. The event is triggered. So if I have this triggering in between, then what I do is I need to clear out the timeout. The previous timer is set and the new one is okay. Let's see more in detail. Debounce. Like debounce switch is wait. A debounce switch is something. It's a okay, electrical thing, right? So what does it do? So this is how a debouncing graph looks like. I mean, okay, switch now. What is switch debouncing? When a okay, uh, So what is saying, when a common mechanical, so when you push this button, so this is going to get completed, right? The problem arises that the contacts do not go from a state of no contact to contact cleanly. The contacts rub against each other and they're going to keep on bouncing. So keep on bouncing and until you get that stable thing out. Mm, let me see. Okay, so this is how the graph is. Okay, so here the events are triggered. This, okay. So it will take some time to for it to become stable, right? This is okay. Why is the switch not ideal? Okay, debounce. Eliminating oscillating button switch inputs. Okay, so what is going to happen is when I close this switch, so it won't immediately have this connection, right? It might keep on fluctuating, and then after some time, this connection will happen. Okay, no, this is. Let's see more examples. Okay, so button switch versus rebounds. Okay, sometimes so annoyed to. Okay, so what is happening is, so this is taking some time to for it to become stable, right? So for this time, if you have any events, okay, if you have any events coming in, so this is how debouncing is going to look, right? For this time period, you have, you see, this is not stable here, right? So this is not stable. So for this amount of time, until this time has elapsed, only then it is going to become, or this stable connection is going to get established. So here we press the switch. So it's not immediately changing state, right? It's taking some time. So this time has to pass. Like we have to make sure that this time has passed, and here it will have different states, on off, and we'll keep on having that state. So on similar lines, suppose if we are having an input button, right? Okay, let's see an example of input button or something like that. So this is an input button. So people are going to enter, right? So we don't want the text to appear immediately. Instead, what we'll do is we'll wait for a certain amount of time to elapse, and if in between there is any key being pressed here, uh, the previous timer, which was, so the moment to start here, you are going to set a timer, right? So this timer has to be cleared out. Okay, for example, if now from here you are going to start another new timer, this event of typing is basically like pressing the switch button, right? So every time you press a switch button, you have to wait for a specific amount of time for it to become stable. So I initially pressed here, and it is going to take this much time, right? But then I also pressed here, so now I need to wait. I need to clear this off, saying that again an event was, or a button was switched, so I need to wait this much time. Now if I trigger this as well, and I have to cancel this and wait for this to happen, If I trigger again, then I need to cancel this and then wait. Let this wait for a specific amount of time. So every time you come across set interval, so the way we can keep track of time here is something called as, so every time you do set interval or set timeout, uh, every time you hit this key, you get a unique ID, right? For each so you get a unique so you get a unique interval. You get a unique what do you say, ID, right? Every time you kind of start this set interval. So what we need to do is we need to keep a track of this ID which is being generated firstly, and then once and the moment we call it again, we need to clear that. We need to clear the previous one and start the new one. Okay. So if I clear this unique ID of the previous session, then that data is lost, right? Um, if that data is lost, then uh, that data is going to be lost, and then I need to start a new one. So this is how set timeout is going to function. So uh, let's see. First thing is we need to maintain. Okay, so when we code, the first thing what we need to do is you need to have you need to track the timeouts. And okay, second, okay, let's get rid of this. So first, basically, we need to track the timeouts and then uh, clear the timeout. Uh, every time we invoke, okay, a new function, or every time it is we invoke, we need to clear the timeout. So we need to perform two things, right? First is track the timeouts, then is clear the timeout. Okay. So to track a timeout, we can do something called as we can every timer will have its unique ID. Now the thing with functions is the local scope is so how to track, like if we kind of declare a variable locally, and every time that function is going to invoke, the previous is going to be overridden, right? So what we need to do is, we need, if we do a local variable, then we won't be able to track it, the previous one. So what we do is, we kind of use a global variable so that we can track it, and then we can clear it. So yeah, this global variable will be retained, right? Even it is going to retain the previous timeout, like when the previous timer started. If we keep it a local scope, then every time we call it, it is going to get overwritten. Yeah, so that is not a good idea. And then we clear the timeouts. Okay. Okay, so let's say that this is our debounce function, right? I mean, so let's say this is our debounce, which is calling, and then inside this, we have something called as okay. So what we inside, so we need to set timeout, right? And then after that timer has expired, we are going to call a function, and then this is my delay, which is going to get passed. And now we need to keep this track, right? So every time we come here, or like every time this debounce is called, we are going to have a timer id that is going to get returned, right? Every time the, so if the delay has not expired, or if the previous id, so yeah, so this callback is going to get called only once the delay present in here will get called. So okay, now mm, okay, set timeout is, and then we have the timer id being kept track of, right? So basically, okay, now this timer id, we are going to make it a global so that it can, we can retain that state, right? And then what do we need more? Are we passing in something else? So there has to be a function that is that is going to get fired, right? Every time we uh okay, I got it. For example, if I type in here, so this is, There is something that I'm not. So this is that inner function. Oh no, wait. This is my debounce thing, which is going to happen. This should be triggered on. So the move. So this will be triggered on every input, right? Every key press or every character press, I need to hit this statement. So this is what is my event triggering the debounce. Now, what about this delay? I need to keep something to have this delay as well, right? Okay, so I'm going to wrap it around in a function so that I can pass in the delay for how many seconds this delay has to there. And then what is this callback function that I need to call after the delay has been expired? But what is hmm. I need to keep a track of the demo. So I need to keep a track of what is being typed as well, right? Okay. Then Yeah, so I need two functions, right? This is my callback that has to be called. So I need to store this as well somewhere. And I need to get the delay as well. So this has to be triggered on every call. And I'm going to keep a track of the timer. Okay. I see. And there are two ways. Either you have this global, or since functions are object, you can wrap this in another function and maintain this closure as well. You can do one thing that way, or you can have a global variable declared as well. So okay, first let's write the innermost function that we need to call, right? So first is basically are going to the innermost thing that we need to call. So let's have you can either name it, or well, let's keep it anonymous. That is not going to make any. This is my inside thing that needs to be triggered on every call, right? So here I'll be having my set timeout, and then I'm going to have a function and a callback being passed here. Let's keep that as well as a no, arrow only. So now this is my function that needs to be called. Now I'm going to define here some. Let's have this like debounce, and then now here let's pass in what we so let's pass in a function, and let's say this is my delay as well. Now either I can have the timeout, or either I can um, declare the timeout here. So this is let timeout. That is because okay, right now so timer ID, right? So I need to store that timer ID. Now here this is unreachable, right? This thing is not reachable inside. That is why I guess we are getting that error. Does it say unreachable? So what so what I'm going to do is let me return this out so that so every time I come here, so when I call this debounce, and then okay, now the way this is you type in debounce and then you pass in another function here. So that function has to be defined now, the one which is going to get called. Okay, so let's see. Yeah, so let's define a function outside so that we can pass in here. So let's say function hand. Suppose this is no parametric. And this is my high, right? So now in my debounce, I'm going to pass this handle search, and then I'm going to mention the delay as well. So this is 10,000. So my set timeout second parameter is fixed, right? This is my delay, and then what I need to call, or this what my callback should contain is my call to the function, which is, so I'll do func and then just call it. Okay, so I guess now this should work. So now when I go to terminal, so you do clear and then yeah, you just run it. The function is okay. Am I printing anything? Oh, you have to wait. This will work asynchronously, right? So how will we? Well, let's open and link this to a script and say let's do hr of Now let's open this with live server and see whether, let's get this out here. Let's go to inspect and see what's happening. Okay. So am I getting, so it's only this is how debouncing should work. I mean, because this is going to get triggered after some time. So I mean, even if I call this, yeah, because this is going to work in behind. So okay, let's. I guess this will come in my output maybe. Need to do. We need to close the shell on this. Let's. Shouldn't come here. I don't know. This is how it's going to look. So either of you can have this timer ID being here, or what you can do is you can create a global object which is again going to be present, right, until the reference is not lost. So you can have it here as well. It's not going to make a. Oh, so this is not completed, right? So now I'm setting this timer. Okay, so now every time I'm going to call, before what I need to do, or before I'm going to return, is I'm going to clear that, clear my timer ID. So you do clear timer out, and then initially it is not going to be anything, like you're going to have null present in there. And then here what you do is you get the timer ID from this. So you do timer ID is equal to okay, so now let's see. Okay, so this is how it's going to work, right? This is my debouncing, right? Now throttling is something else, right? Let's see how throttling is going to work. uh, we are making sure that the only after this timer has elapsed, the function passed in is getting called, right? And there is something called as okay, let's go to, now we need to go to throttling, right? So throttle is more commonly seen when you have uh, is to basically limit the rate at which a function is called executed. It means that the function is called in a specific time interval, and if the event it's responding, okay, The throttling occurs in by like you throttle a bike, right? Mm. So we are going to limit the rate at which a function is executed, ensure that the function is called at most once in a specified time in interval. So that means if you have a time interval being mentioned here, so it will be called once. So suppose this is my interval of say 100. I need to call it in once here. The function is called at most once in a specific time, even if the event it's responding to is triggered. So uh, just call it once. No, that is used to limit the rate at which a function is executed. Ensure that the function is called at most once. You call this at most once is max. Uh, there is some. Let's see what is throttle like. So the way throttle is by which a fluid is managed. Okay, let's see. So how does it happen? Like how do you throttle a bike? Let's not go to images. Let's see. Oh. Control the bike speed with a simple twist or press, eliminating the need for constant pedaling. Okay, a bike throttle works by continuing the power flow. Okay, so that means once I press this, it should remain for a certain amount of. So, for example, you have a bike, right? So when you press or you throttle it, it remains for that speed for a certain amount of time until the energy is dissipated, right? You do not throttle in between. Like, you do not pedal in. So like pedaling, you do continuous pedaling, right? You need to continuous pedal to keep that speed. But throttle is once you for a certain amount of time that will be kept and still uh, until that time has elapsed or something like that. So even in my debouncing, am I not limiting something? Okay, yeah, this is my debouncing. So here as well, I'm reducing the. No. Here I'm clearing it at every time, right? So every time a new event is occurred, the timer has to start from there. But here the timer has to be maintained since to check that whether the time has elapsed or not. Only then is when you're going to clear the timeout. For example, I started at 10 a.m. and I say that my throttling is for 15 minutes. Say. So the next time I need to check is at 10:15. So if at 10:15, okay, yeah. So the next, this is not that. Okay, so yeah, if at next time, that is at 10:15, I'm going to hit the throttle again. This energy is going to be maintained till this period of time. First is basically I need to check when last time was I getting the throttle. What is the current time elapsed and how much time is remaining for this to come. So basically, um, the time I started minus. Oh no. I guess what is I know. It has to be 15 seconds, right? In all. This is when I started, and this is my okay. So if my starting time minus my current time, if that is equal to the difference, that is 15, then I say I have achieved throttling, that time difference, because this time is going to be more, right? Oh yeah, in time sense if you say, because if I start at 10 and this is going to be 10 1, so this subtraction won't be proper. Okay, let's, yeah, actually we are not, yeah, I guess. So what is going to happen is you do current time minus the last time or minus the time you started. So if this difference is going to be 15 on my time interval, uh, then the next throttle has to occur now. Okay, this is when I'm going to make the next throttle. If this difference has not elapsed 15, then I need to wait till 15 is elapsed, right? So don't call the function wait. Oh, so yeah, I get. So I have two things, right? My current time. So let's say this is my current time minus my starting mine, and say this is greater than my total delay time, or the time that I want the throttling to occur again. So there are two cases, right? Here. So if it's greater than equal to, then I come here and then I say do throttle again. Energy has elapsed now. Throttle it. So you do a throttle again over here. However, if here you come and say so if this has not elapsed, so if my I'm still in my less than zone, then what I do is don't do anything. Instead, clear the timeout. So clear my timeout right now, and wait for the delay to happen. So what will be my delay and clear timeout? No, I am clearing. Or I say you set a timeout over here such that that timeout I will have to wait for a delay seconds. That for a time that is equal to my throttling time. That's the next throttle that I need to do. So how will I be calculating this? This current time. Okay, so what was the current time minus the last time I came in here, and then minus the limit, like how much I've set. If I do this subtraction, then I'm going to be exactly at the next time. Is that what is happening? Okay, basically I need to maintain if I am in between, say I am less than, now that time what I need to do is I need to check whether the time has elapsed or like that will be less than my time elapsed, right? Like I won't be able to satisfy that. So I need to don't make the call, but oh yeah, so what if the time has not applied? So like what if that energy is still remaining? So and if energy is still remaining, you don't throttle it. Instead, you make it wait until the energy lapses. So now your energy is still there. So I say my energy is still present. Like we are taking an example of bike, right? So in bike you have that throttling option. So if you say you still have the energy left, now what you do is you make it wait until energy will be lost totally. So you have this totally lost energy, and once the energy is totally lost, then you can make that call, right? So we need to do that. See, where in case in debouncing, if you see, so this is what is going to happen in case of debouncing, right? And then, let's see, we are going to have this wacky noodles, and then where we are going to get this straight line. So what we need to do is, for suppose I started this, I'm here, I press the switch here. If I press the switch here, then it has to wait this period of time, like, because the stable output will come only after 10 milliseconds. So what if I press the switch again? If I press the switch again, then again I need to reset the timer, because now the timer is not, suppose this I got at t equal to 0, right? Okay, let's have this thing as suppose this I got at t is equal to 0 and this is at t equal to 10. So if this occurs at t equal to 10, again I need to wait for this much period of time, so that uh, it will, so I need to wait for 10 seconds, right, until I get the stable output. What if I get another input here? So basically I'm going to clear the previous, because the previous timer will be an indication of this, right? I need to start a new timer now, because the switch has been pressed. So if I press it at, if the switch is pressed at say time equal to 15, I need to start a new timer again, and then I need to wait again for this period of time. So sorry, for this period of time to get a stable output. Well, in the case of throttling, what we do is, the throttling we say, this period, suppose this is 10. So once if I start, if I give my first throttle on my bike, this is my bike accelerator, so it will remain inactive for 10 seconds. So if you get any okay, so if you get any throttling in between, you want, don't do anything. Instead, make, for this to work, you have to make this work, or make this wait till 10 seconds, or make it work till this timer is elapsed. So basically, now for this, if time is elapsed, so how will you calculate it is, the present time minus the time at which the event occurred. If that is equal to or greater than my throttling time, then I can give a new throttle right over here. So this is the new throttle can be pressed. But what if I fail this criteria and get a throttle in between? So I need to wait for the amount of time which is being elapsed. Even here I'm waiting, but here I'm saying each switch press is going to take a specific time to come. However, here I need to retain, like, so I need to mention this time, when the previous, and what time this occurred. So I need both of these times. This is like when a person keeps on pressing key, you do not type, put in the input bar. Now if it becomes stable, there is no key press, then you input whatever you had written over here, saying this is what item that I need to search. So here the best example is scrolling, right? So we say that a scroll event will occur, so that scroll bar should shrink only after certain amount of time. So if the user has completed this much time, we are just assuming that the user is now on the bottom of the page. Then this event needs to be triggered. Because even if the user can scroll down very fast, right? So how to make sure that the user is reading content and not just skipping through or skimming through? So you kind of make the scroll event happen only after one. For this is, for example, training, right? Training modules which you get, you tend to just scroll down through. So but then they need to make sure that we are reading the module, right? There you can use throttler. That is, that scroll bar will remain inactive for a certain period of time, making sure that you are reading that content, like bike throttling. That energy is still active. Okay. I guess this is all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye.